Imitation crab?
No, I went with chicken. I got the regular chicken this time.
Gathering, conference,
You know, I did that imitation crab again, and it wasn't as good as I remember.
and
I don't know.
then minutes.
Because I was talking it down?
Yeah, keep recording what.
Probably.
All right, so before I open up the floor to general questions, I just want to go over a couple things. Some things that I'm still seeing in the homework is some people are still struggling with how to resolve uniformly distributed loads. And then we're getting reactions switched up sometimes too. So I just want to walk through that again quick, and then we can look at just kind of any general questions that you have. We talk about the exam, whatever it is that you want to talk about the rest of the time. Okay, so what we have up here is we've got a 14-foot simple beam. We've got a uniformly distributed load of 100 pounds per foot over the left 6 feet, and then we've got a 300-pound load 4 feet away from R2. Okay. So, first thing that we need to do is figure out what our reactions are. Right, we don't have anything in the X direction, correct? So what do we have going on in the Y direction?
R1 plus R2.
Okay?
Minus 300.
Minus 600, right, or 100 pounds per foot multiplied by 6 feet. R1 plus R2 equals 900 pounds, right?
So
Yep.
minus 300.
300 and 600?
So we don't take that in the middle? The 100 times 6, then times it by 3?
Good question. Not in this point, because here we're just looking at our forces in the vertical direction, right? We're not looking at moments yet.
Okay.
Okay? Once we get to our moment, that's when we concern ourselves with that. So, do we want to look around R1 or do we want to look around R2?
R1. You want to do R2?
I mean,
Do R2.
it doesn't matter either way, right? In the grand scheme of things, right? If we're performing the calculations correctly, we're going to come out with the same answer. So we're going to look about R2. So what we have to remember is that if you're looking at your moment about R2 is not going to create any rotation, right? So it's not going to factor in. You have to make sure that the distances you're using are measured from the point of the application to R2, okay? Sometimes people are taking about R2, but then they're using this distance, okay? And that's flipping everything up. And it won't give you true equilibrium. So make sure that you're aware of what this means. Okay, so this means that we're taking the moment about R2. Okay, so everything has to be measured at that distance. Does that make sense? To everybody? Okay.
And when you do that, you're going to come up with R1s.
When we do that, what the equation's going to kick out R1.
See, I think
Yep.
that's where I get messed up is when we're solving for R2 and then I get all the math done or whatever the case. I'll be like, okay, that's R2. And then I'll do the math and then, okay, and that'll be R1. So
Right.
when you're doing the moment of R2, you're solving for R1.
Yep. Yep. And I would recommend on your homework, write out all this stuff. I know it's a pain in the rear. Believe me, I know. I took an entire semester of statics. I took an entire semester of deformable body mechanics. I keep forgetting to dig out my homework. I'll bring in my homework notebook sometime when I find it from down in my basement. I went through over a notebook in each of the classes. I get it. It sucks, right? But if we write out all of our notation and if we use all of our accounting, it makes it much easier, okay, to keep track of where things are at. So, what is causing rotation about R2?
300 at 4 feet.
Our 300 pound, okay? Is it rotating in this direction or is it rotating counterclockwise?
Negative.
It's a negative rotation, right? Okay? So minus 300 pounds times 4 foot, okay?
And then you got negative 600 at
Would that be at 14?
11.
At 11 feet, right? Does everybody see where John's getting that?
Yep.
Because it's halfway, that's when you go halfway through, so it'd be the 8 feet and the 3 feet.
Yep, so John is taking the 100 pounds per foot, multiplying it by 6 feet, okay? And he's resolving it at this point. Okay, so he's turning it into a point load,
Yes, he is.
and that distance is 11 feet away. Okay? What I've been seeing a couple times is sometimes people will do this and they'll use 3 feet. Okay, so again, that would be if we're looking about R1. But here we're looking about R2, so we need to make sure that we're measuring that distance. Okay? And is that giving us clockwise rotation about R2, or is it giving us counterclockwise rotation about R2? Counterclockwise, right? Okay. What about R1?
Wait,
Positive at R1 at,
but it's at 11 feet.
what's that, 11?
So won't it be 6
Oh, yes.
divided
Yep.
2 plus 8?
Yep, sorry. Thank you.
Yeah, you're good. What?
Because it's the 8.
I know that, I know that.
Yep, thank you for pointing that out, Rush. See, it's very easy to make that mistake, right?
So that's it though, right? Oh, R1,
And then how far away is R1?
14.
14 feet. And is it trying to rotate in a clockwise manner or in a counterclockwise manner?
Clockwise.
It's trying to rotate in this direction, right? Oops. So it's gonna have a positive value. Okay? So R1 then equals 1,200 and 6,600. That gives us some nasty number, doesn't it?
Yeah, it's like, I got 557 point, just 557.
We'll just call it 558.
It'd actually be 557.
557.
Negative 5.
Okay. So what does R2 equal?
Negative. Oh, yeah, I just did the positive, I just did 7,800. So you take 900 minus 557,
Yep. So 343.
yeah.
Okay. Does that make sense to us? Does it seem realistic that we'd have a smaller reaction requirement over here at R2 than we would over at R1?
Yeah.
Makes sense, right? We only have a 300-pound point load over on this side of the beam, but we have 600 pounds over on that left-hand side.
And
Okay?
they're both positive.
They're both going to be positive. Yep.
Everything's pushing down. You know what I mean?
Yep. Yeah, remember that it's really only in our trusses. When we have that vertical load where it's trying to tip, that's when we'd have a portion of our truss try to pull down on that system. Okay? And as long as we're mindful of this, on the shear diagram stuff, sometimes people had the magnitudes correct, but then they'd have the drawing flipped. So if your magnitudes were correct, but your drawing was just flipped, I didn't subtract any points from you. Because, again, remember, our beam doesn't care. Beam doesn't care how the shear force is being applied. Okay? So those are the only two big things that I'm seeing people kind of repeatedly trip up on. There is one, it's a very short assignment, it's one problem, due by midnight tomorrow night. Knock that out and I'll get it graded Thursday morning before I get the kids on the bus and head down here. So you'll have your feedback on that. I've got C and D left for assignment 5, and then I'll get that key posted for you and get that graded this afternoon. Jay, when I was grading homework 4, your PDF wasn't showing up for me, so I'm gonna see if now that I'm on the school network it shows up. Otherwise I'll reach out to you and just have you resubmit it. So that's the only reason your score is lagging. Questions that you have on the midterm?
Is it on Thursday or after spring break?
No, it's on Thursday. Yeah, there's no reason for us to leave here for a week and,
Forget everything.
yep,
Right.
yep. Yep, we'll wrap up with the midterm, that'll be the last thing that we do. That's how I would have liked all my classes to have been when I was in school, so. Not all of my classes were that way, sometimes they would have it the first time you'd come back from spring break, and I think that that's a real jerk move to do.
Hey, Ben,
Exactly.
did you get, I'm missing part of my.
Terry,
What?
don't.
Wasn't 4 A through F and A through D? What?
No, that was 5,
Oh, okay.
that was 5.
I missed
Yep.
one, alright.
No, 4 was just A through F. Because remember, the first part of assignment 5 was going back to the shear diagrams
Yeah, well,
for that assignment and
I'm looking over your notes.
doing the bending on them. So,
Ben, I have a question.
Yes.
So are, you said the test was on our computers or? it
Yep.
was-
we'll run it through Canvas. So the thing they'll ask is, just like with the homework, make sure that you bring some note paper, scratch paper, whatever it is, to perform any calculations and turn that in,
Margarita last night.
okay? Because all the computer is gonna know is the answer. Okay, so it's gonna spit back one score at you. But if you turn in your sheets, I can review things and we can resolve partial credit from that.
And we'll do that right during, at class time.
Yep, yep.
We're
Yep,
gonna
just
give
when
you
you-
our hard copy.
When you're done, yep, just turn in your hard copy. If, I mean, I guess, and the other thing that I'd say, if you really want to hang on to that, and if you wanna go and scan it in, that would be fine too. I don't have any issue with doing that. I can set up a spot for you to scan it in to submit as well.
Sure.
So, it's probably gonna be about 16 questions, but out of those, easy, you didn't let me finish the sentence. There are gonna be, probably about 4 of the questions are gonna be the definition type that you got on the terminology quizzes,
Oh, shit.
okay? Just,
I was digging back.
what?
So that's digging back. That's digging deep.
Yeah.
Like beginning of semester deep.
Are they gonna be multiple choice?
I don't think
or
there's
like
anything you can
bullet
say
point?
that we're not gonna bitch about.
Yeah,
at
that's
this
true,
point.
that's true. Yeah, it'll be,
These are notes and stuff though, right?
absolutely, yeah,
Oh,
yeah.
all right. That's
So, yeah,
You're-
you can just bring up
yeah.
our old term. for it.
You guys can bring,
beautiful.
you can use whatever it is that you've generated from this semester. You can have your book. Keep in mind, well, yeah, you can't use your friend's stuff, but
Is it gonna be in that lockdown browser?
no, no. No,
So my book on my computer.
yeah, no.
Kurt, shut up.
How do you do work in the real world?
With other people.
Right?
Yeah.
Well, okay. So we have to draw the line, somewhere, right?
Okay.
Okay, you have to get an individual grade. But
That's also true.
the expectation is never in the real world that you have to be able to pull everything from your brain, right?
Right.
So, what's that?
Give resources.
Yeah, so you
On
have
that-
your design manual, you have previous projects you've worked on, right? Where you can go out and
Are
be
you
familiar with.
doing, is there, how many of number assignment 6 is on there?
You would get part of one problem.
Okay.
That would be it.
Dude, is that open?
It would just be a
Oh, it is,
quick
yeah, it
check.
is open, actually.
Yeah.
What's it look like? I'm just
Let's take
curious.
a look at this thing.
Yeah.
So can we keep going through, you said forward definition type, can we keep going through that or no?
Complete.
Or is that
I
just about
haven't,
it?
I haven't figured out what they were, but
For
they
page
will,
171.
I mean, they'll come out of the
4.5.
terminology
Yeah.
quizzes. So,
Well,
it'll
we
be-
just buzzed through this problem while we're on here.
171.
it'll be something from the text
The width structure.
where it's a
is
definition.
proposed
I
respective
mean, it'll be,
of
it's gonna be terminology that we've been using throughout the semester. So if it doesn't come to you very quickly, it'll be fairly easy for you to look at. So, no, there aren't gonna be curveballs.
Holy crap, man.
It's not the purpose of testing. So,
So,
go ahead.
that's a hell of a word problem. Oh, I was just looking up.
What's the deal?
So 1 to 3 was, height to width?
It's height to width for your shear wall, right? But it's also length to width for your diaphragm, okay, your flooring system.
And you said length to width?
Yep.
So we're good there.
So it's the check that you want to use when you're looking at it in plan
So this is 160.
and when you're looking at it at elevation.
Determine a preliminary design for the roof joist, beams, and exterior walls.
So all you want us to do is just say like, we want some 2x6s for the exterior walls and some 2x4s for the interior walls.
Well, and size the joists,
Oh,
What
right?
are you supposed to do in this mess down here?
okay.
Check your diaphragm, check your shear wall. Are you gonna, is it gonna be fine to run it with just an exterior shear wall? Or are you gonna need interior shear walls?
And you would look at the footprint for that, right? Because it's 100 by 50.
Mhm.
That's 1 to 2,
Yep.
so it's fine. But on the height,
So you want,
so it's 13 and a half.
so you want 2x12s for your roof and floor joists, so it can span the 21 feet with your 8-foot corridor in the middle. Boom,
Do you take
done.
out the corridor?
Problem done.
You take it
No,
out.
That's it,
well,
yeah, it's just a preliminary design. We'll talk about this stuff more after spring break.
Yeah, well, because your floor joists are gonna be running this way, right?
Can't use
Your floor
corridor,
joists will be running this way. If there's an 8-foot corridor right down the middle here, your span is 21 feet on that, so you go back to this chart right here. For a span of 21 feet or more, you need 2x12s.
Okay.
So
So it's
do
asking, is that what it's asking us for the design of the roof joists and beams, exterior walls, columns, roof joists? I don't know if it's that was. So is it different for roof?
Read them over.
What page was that on, 161 or something?
168. Look at the page before that.
Yeah, it is, so roof joists and floor joists are different.
Yeah, but.
Oh, it's the same,
It's
okay,
still
I got you.
the same. You need 2x12.
Yeah. Yeah, keep in mind, the problem does tell you corridor walls cannot be used as bearing walls.
So does that mean you,
So those can't be used for like the 2x12 for to bear,
Correct.
that's what you're saying, okay.
so you need a 50 footer,
50 foot span.
so there is no 50 foot span, so we'd have to have two. What do you do there then? So does that mean you gotta put beams in there or something?
The corridor walls and space bearing walls provide flexibility, but should be where columns are placed. There's columns in the wall?
And where, the
Is that
corridors?
what's going on?
We have columns supporting,
The exterior,
yep,
but no columns in that corridor wall? Is that what you're?
Cause no beam can go 50 feet. You know what I mean? So if you gotta run a beam all the way across, or what am I calling it, a joist, I mean,
mhm.
a roof joist, does that mean,
Floor will reinforce the beam.
you gotta put 12-inch beams? What's a beam?
That's a column. Beams are load bearing, horizontal.
Mhm.
So you're gonna have to put beams in there, somewhere, I don't know, 50-foot beams across. No, I'm not a carpenter, man.
I know, I can barely even read this
I'm
problem.
trying to picture like framing it. Steve, well, what's the answer? to
Yeah,
this one? You're a
Steve.
carpenter.
You use floor truss, not use the joists.
I'm a carpenter too.
You're a carpenter. Yeah.
What's that?
You're gonna have to use an engineered truss for,
Where is that in the table?
Well, yeah.
it's in Burnsville over by, it's what you hired out.
I've got my notes. Hmm. That doesn't help at all. To provide flexibility, but should be where columns are faced. Where's the column? There's no column. So would you do 3 different ones, like two 2x12s and 2x6? So like 2x12, 2x6, 2x12?
No, because these walls right here can't.
These are wood for us to
But
figure
it
out.
says that's where
It's
columns
like,
should be
it's like
placed.
No, not at this point.
Just say it's a floor truss at 2 foot centers, 50 feet long.
But it
Yep.
says,
Yep.
the border walls are not to be used as bearing walls to provide flexibility,
See
but
what
should
big
be
ones
where
are,
columns
wide
are
ones are,
placed.
and, you know,
No.
and stuff.
No,
So you can put columns in
we,
that column?
we don't know enough to be able to figure out.
No, it's not.
I mean,
Which is fine, I guess
you- yeah.
The answer doesn't say much
But
other
it's
than.
where
Correct.
columns should be
Corridor
placed.
walls
Correct.
are not used very
Yep.
much,
These are pretty-
but should be where columns are placed.
Yeah, these are fairly vague questions.
I gotta be honest, I don't know how to do this.
I mean, we're pretty much there, I just don't know how, I guess this is engineered floor joists and roof joists. Floor joists. So we're gonna need shear walls. Is this greater than 1/3? The ratio. Wall.
Where?
Is that
It's only 1 or 2.
You know, it's greater than 1/3. 1/2 is bigger than 1/3.
Shit.
So you need the shear walls, so you have 2x6s, exterior shear walls. 2x6s.
I could do more weight.
Yeah.
For the night.
So what do you think? man?
Maybe right here.
Where'd you have 2x6 then?
Hmm?
Would you 2x6?
Let's just read the whole thing. them.
Is it asking us to solve for that though?
Yes, it sure is.
Determine the preliminary design for roof joist beams, exterior walls, roof joist, so.
Oh, so that's due.
So you take into account for the 3 foot and the 8 foot there on the section? I'm guessing on the section you gotta figure out if it's 1 to 3. So it's got a 3 foot, I don't know, roof.
I'd use this whole section initially
Okay,
for your shear wall.
so it's gotta be 13.5.
Just think of it as your exterior wall first,
I
right?
did too, I'm just gonna say that,
So,